Welcome back, engineers. We are discussing common techniques in algorithms and system design, and we've already covered the theoretical aspect about how operational transformation works in one of the previous videos. And in this video, let's have a look at a demo about how operational transformation actually works, right? So we'll try to create a simulation about a multi-user editing situation, and we'll see how the server actually handles it and how the transformations actually happen, right? I hope you're ready. Let's get started. So before we go into the demo, let's have a quick recap about what was operational transformation. So this is mainly used for collaborative editing, and apps like Google Docs mainly use it. So when multiple users are operating on a single document, let's say, every space in the document is divided into indexes. For example, if the word is HELO, H is at index 0, E is at index 1, L is at index 2, O is at index 3, and so on. So every position is indexed. So whenever a user is changing something, we are sending an operation, something like this. So insert L at index 3, right? So we're trying to give a position and also what is the text that needs to go there, right? The problem occurs when multiple users actually try to perform operations at the same time. So let's say both users are at the start position, HELO, and we are trying to insert different things from different users. So user 1 is saying insert L at index 3, user 2 is saying insert exclamation at index 4, right? So this is a conflict because both of them started at the same version or the same position of the document, but now they're trying to do different things, insert at different positions and with different text. So here is what the server will do. It will accept one of the operations, insert L at index 3, which is accepted. So we have hello exclamation, no problem. And the server transforms the other operation to get us into a convergent state, right? So instead of insert exclamation at index 4, we now have insert exclamation at index 5. Just indexes right shifted a little bit, and now we have hello exclamation at both the places, and now we have a new server version to work with, right? So this was a theoretical understanding of it. So there are multiple users working on the same state of the document, and they're trying to give different operations, and there is some kind of conflict resolution to get us into convergent state. So let's try to look at a demo for this. So I've created a simulation. This is not exactly a real-time editing document, but we can actually understand what's happening on the server side using this demo, right? So there is a server state with revision 0. This is the first state of the document, and the text is hello world, right? So whoever is connecting to this document is seeing this text hello world at revision 0, right? So let's say there are 3 users working on the same document, and they're trying to give operations to the server at revision 0, right? Let's say user 1 is saying insert beautiful at index 7, user 2 is saying insert amazing at index 7, and user 3 is saying insert wonderful at index 7. So all 3 users are trying to send insert operation to the same server for the same revision, which means the current state is hello world, right? So let's see what happens. So I've created a simulation log so that we can understand if there were any operations performed, and if yes, what was the operation, right? So let's see. So user 1 is sending operation type insert position 7 text beautiful based on revision 0, right? And user 2 is also sending the same thing based on revision 0 with text amazing. User 3 is sending insert for the word wonderful based on revision 0, right? So all 3 users are at the current state of revision 0, and they are sending 3 different things to the server. So let's see what's happening here. So user 1's operation is accepted. Server is now at revision 1. Original operation insert position 7 text beautiful. Applied operation is also insert position 7 text beautiful, right? No change in user 1, right? So when the user 2 is sending the same thing, we now have a transformation. So the original operation requested was insert at position 7 text amazing, but applied operation is insert at position 17 text amazing. Why? Because when user 1's request was processed, we have revision 0 and the text beautiful was inserted. So the server understands this when user 2 is also sending some kind of operation at revision 0, which means that user 2 is out of sync from the server because the server's current position is revision 1, right? So how do we catch up user 2? We check for all the operations that were performed at revision 2 to revision 1, whatever have been the operations. So we apply transformation and we get this result. So we need to push the position to 17. Now the text is beautiful, amazing. So the same thing happens with user 3 as well. User 3 is saying insert the text wonderful at position 7 based on revision 0, but now our revision of the current server is changed to 2 after processing user 2's request. So user 3 is lagging by, let's say, 2 revisions, right? So what do? We transform it to this operation, insert at position 26 the text wonderful. So that's why we are seeing this wonderful here, and this is the current state of the server, hello beautiful amazing world revision 3, right? So this is how the server actually translates or transforms the operation during insert situation, right? So let me reset the document so we can see other scenarios as well where there is insert delete insert and those kind of things, right? So we are back at revision 0, hello world. So let me use the readme file to help us get through this. So we have already seen insert conflict, which was a demo that I have shown you just now. You can play around with this. Now let's see insert delete conflict. So our current state is hello world. Let's say user 1 is sending insert operation at position 7 with the text new. So we are expecting something like this to happen, right? And at the same time user is saying delete at position 0 the word hello. So user 2 is saying delete this, right? So what should happen now? So if user 2's deletion is processed first, the document becomes just this, the word. User 1's insertion is at position 7 is transformed to position 0, resulting in the final document new world. Let's see if this happens. So we want user 1 to send insert at position 7 with the text new. So we can see this. So let me just uncheck user 3 so that we can understand these operations with user 1 and user 2. So we are saying insert at 7 the keyword new, right? And for user 2 the operation is delete at position 0 for the word hello, right? So user 1 is trying to insert at index 7 with the word new. User 2 is trying to delete for index 0 the word hello, right? Let's see what the simulation will do now. Okay, so user 1 is sending operation insert position 7 text new based on revision 0. User 2 is also sending a delete operation for position 0 based on revision 0. So both users are sending operations on the same revision to the server, right? So what is happening now? User 1's operation is accepted and we have applied the transformation as it is, no change required. So the word new is inserted, but user 2 operation is also applied and we have deleted the word hello, right? In this case there was no issue at this point. But if we were to reverse the situation, let's say user 1 is saying delete at 0 the word hello and user 2 is saying insert at 7 the word new, right? Let me reset the document and we will send these two requests again and see what happens. So in this situation what is happening is user 1's request is accepted, which is the delete request. So first the word hello is removed, which is what we need, and now user 2's request is transformed, right? So the original request was to insert new at position 7, which is now transformed to insert new at position 1, right? Because otherwise there would not be any position 7 after deleting the word hello, right? So that's why the transformation has been applied to change the index to position 1, right? So this is how insert delete conflict works. Let me reset it and we will see the other situation. So let's try to see delete conflict now. In this case user 1 is saying delete the text beautiful in this word, and user 1 wants to see text like this, hello world, and user 2 wants to delete the word hello to see the text beautiful world, right? So what happens now? If user 2's operation is processed first, which means if this operation is processed first, the document becomes beautiful world, yes. User 1's deletion at position 7 is transformed to position 0 because the word beautiful has been moved to a few places, right? Resulting in the word final document world, right? That's what we can see here. So I will leave it to you to actually run these commands and check out what happens during delete conflict. And let's also discuss delete insert. So let's say we have the original state hello world and the operation is delete hello world, the entire document, right? So once user 1 deletes the entire document like this, what happens to this insert, right? There is no position 7. So naturally what should happen is the transformation should be changed to position 0 and the text should be inserted at position 0 and the final document will be something like this, right? But if we were to reverse the situation, insert operation works first, then the text becomes new world, then we cannot delete hello world, right? In this case, this delete operation will be ignored, right? And we are left with the text hello new world, right? Because at position 0 we no longer have this text hello world, because of this there is nothing to delete, and this one will be discarded. So the delete operation is discarded in this case, right? And we will have the document hello new world, right? Let's try to simulate this one. Delete insert. So we are at a state of hello world at revision 0. So let's do the first one. So user 1 is trying to delete at position 0 entire hello world, right? And user 2 is trying to insert at position 7 the word new, right? Which is what we need. Let's see what happens. So we got the final state as new, and as we expected, original operation and applied operation are same for user 1, and original operation and applied operation are different for user 2 because there is no longer position 7 available in the document. So the transformation has been shifted to position -6 in this case, which is nothing but 0, which is adding the keyword new, which is what we are seeing as revision 0, right? If we were to reverse the situation, let's say user 1 is trying to say insert at 7 the word new, and user 2 is saying delete at index 0 entire hello world, right? Let's see what happens now. So first user's operation is applied as it is. We have inserted the word new in this one, and the second operation could not be applied because there is no text called hello world after applying this transformation. So this one will be a failure, which means transformation is not applied. So we just have one revision, which is hello new world, right? So that's how these conflicts will be resolved for different types of situations, right? So I hope that this demo was helpful to you to understand how the transformations actually work. Some of you have been asking me in the comments about how these transformations exactly happen. So I hope this demo clarifies those questions. So definitely play around with it, clone this repo and start the server and play around with it. Let's now look at the code now. So the code is actually quite simple. If you look at the operational transformation, there are these transformation methods. Let's say we are transforming insert against insert. So what we are doing is, if you remember the first demo that we saw where we were inserting from multiple different users, so what did we do was, after the first word is inserted, we move the index a little bit ahead so that the next user's inserts were performed, right? So that's what we are doing here. Operation type is insert, and we are just changing the position by adding the length of the operation tool text, right? So similarly, if we look at insertion against deletion, we are changing the position based on the operation to text. We are changing the position to the negative side. Similarly, deletion against insertion, we are changing the position. Deletion against deletion, we are changing the position, right? That's all that is happening here. We're just changing the position of the operation so that it makes sense. And that's all there is to it in the code level as well, right? So definitely explore the code. Let me know if you have any doubts. I'll leave the link for GitHub in the description for you to check out. Definitely check it out. I have written enough comments and documentation for you to go through the readme file, go through these examples. It has instructions about how to start the server, how to set up the index.html, how to do different types of conflicts. So I've tried to put some effort into this. So definitely check it out and let me know if you have any doubts, right? Thank you so much for watching, guys. I will see you in the next video. Please leave a like if you found this helpful. Please subscribe if you haven't done already. I'll see you in the next one. Cheers.